Hello, everybody, and welcome back to part 2 of our chess video series. Um, Today, the goal is to get the well. Let me start with where we left off. We left off yesterday with this sort of window here where we have all the pieces drawn. We have the checkerboard pattern, so we can now start to play chess. But clicking on stuff doesn't do anything. So today what we're going to do is try to handle user input from our mouse. So it should look something like this when we're finished today, where now you can click on a piece, you can click on a square, and you can move the piece to that square. And if you have two people that know the rules of chess, then they can pretty much play using this user interface, but they can also play like a toddler, where they can move a piece wherever they want, even um, making multiple moves in a row being illegal moves. Um, White doesn't have their king anymore, but it's fine because it's not real chess. It's like toddler chess. Um, but that's the idea, and then we'll worry about adding in the logic for making sure the moves that they make are valid. But right now, we're just going to handle the mouse input, get the two squares the user clicks on, and make the move accordingly. All right, so let's go ahead and jump right in. So where we left off yesterday, we had our main class that handled loading in the images, drawing the game state, drawing the board, drawing the pieces, all that good stuff. So we've got a lot of UI. And you can imagine where we're heading today is right in this event queue where we can handle the mouse events. We're going to have to add a little bit to our chess engine. Namely, what we're going to add today is a move class in order to make said move. We actually need to keep track of two squares, the starting row and starting column, ending row, ending column. And we're going to use a class for that. And we don't have to necessarily use a class. You could just continually keep track of like a list of coordinates, basically, of first click, second click. And you don't have to make a class, but I think making a class makes it a little bit easier for us to. I think it's a good abstraction. It makes this a little bit easier for us to program when we can just etc. So let's go back to the main and let's go into our event queue here. Right in here after running false, and we're going to start by putting in the mouse event handles. So if you'll recall from our earlier Python Pygame coding, we've done mouse clicks before. We look at the event type is, and here we're just gonna do mouse button down. Now, there are some engines, like if you play online, a lot of engines will let you click and drag the piece to the square that you want to move it to. We could add that functionality in, and maybe that's something that we'll add in on a later date. But for right now, we're just going to simply have the functionality where we click a piece and we click where we want it to go, and it goes there. So we'll keep it simple. It's the simplest way to do the logic. Again, we could make it a little bit more complicated, and maybe that's something that you want to try on your own as well. All right. So we have this location where we're going to keep track of the mouse X and Y coordinates. Get position. This is the XY location of the mouse. If you do add a side panel in here, then you do just have to make sure that when you're dividing by square size in this next few lines of code, that you're keeping account for like the side panel or the bottom panel. So if you're going to add extra stuff to your display or a border or something like that, you just have to make sure that the mouse location is relative to those new set of boundaries for your board. But since our board is the entire screen, we don't have to worry about that. Keeps it really simple. So the mouse column will, you may want to pause and think about, we've done this a couple times before, so maybe you can remember how you would get the row and the column that the mouse is located in on the board, given its X and Y. See if you can remember how we did that. And if you recall correctly, it was we took the X coordinate of the location and divided it by square size. Square size being this height divided by dimension. So all the squares are equal size. We do double divides to round it so we don't get an error later on when we draw. And location 1, square size. Actually, I don't know if we're going to be using these variables to draw, so you could probably get away with single divides as well. But, so this will give us a row and a column. No, I take that back. You definitely need double divides. We need these to be integers. Okay. So the column and the row of where we click, now we know what piece we selected, basically. And so we're gonna use a couple variables here. So the tricky part here is if the user clicks on a variable and we store that in row and column, but then they click another piece and we store that in row and column, we have two variables trying to do two jobs. As in we are trying to keep track of where the user clicked first and then where they're trying to move the piece to. But if we only have one variable for that, one row variable and one column variable for that, we're going to run out of, we're going to forget the first space the user clicked on whenever we remember the second space the user clicked on. And so, there's a bunch of different ways you could do this, but an easy way that we can do this is just to create we're going to use two variables here. First off, I don't want to keep track of a row and a column. I'm going to make it a tuple and call it square selected. So I'm initializing these variables up above the while loop so that we can continuously reuse them, and they have the scope of that is located in the entire while loop. So we're going to not just use them inside this if statement, but we might use them, in a couple different if statements. So we're gonna keep it out here, and basically I'm starting off with square selected being empty. No square is selected initially. And we can also use this later on for syntax highlighting. But this will simply keep track of the last click of the user. And it'll be a tuple, meaning it's going to be a row and a column like that. A little more clear. And then we're going to have another variable, which I'm going to call PlayerClicks. And this will be just a list, but it's only going to have two elements in it, or up to two elements. It'll have 0, 1, or 2. And this will keep track of the player clicks. So it will have basically two tuples. And so we can imagine that this is going to look like, for example, maybe the user clicked on row 6, column 4, something like this. This would be one of 7. 4. This would be one of white's pawns. Oh wait, no, 7 would be the back rank. Yeah. See, this is why we use rank file notation. It's easier to visualize than this row column notation. And then maybe we're moving that pawn up 2 rows, so maybe to something like that. And so when the user clicks on square 6, 4 and then clicks on square 4, 4, player clicks would look something like that. So hopefully that makes sense. Now, what we're going to do now with this information that we have is we're going to just store it in this square selected variable. So we're just going to store row column as a tuple in square selected after we click on a square. Now, here's the thing about this. What if the user clicks on the same square twice in a row? Essentially, what it would be telling the computer is move this piece to its own location. And we don't want that to be the case. We don't want that to be a valid move. Oftentimes when you click on something, you're kind of highlighting it. When you click it again, you're unhighlighting it, you're deselecting it. So the first click is a select, the second click is a deselect. So what we're going to do actually here is we're going to check to see if the user previously selected this square. So we're actually going to, before we assign square selected to this row column, we're going to actually check if it's already equal to row and column. So this basically means the user clicked the same square twice. And this is typically an undo action. That's what we want it to be. And so if that's the case, I don't want to set square selected to row column. I actually want to unselect it, which is setting square selected back to empty. So deselect or unselect. And in that case, we're also, in case we had previously saved player clicks, we'll also reset and clear the player clicks. And it's basically just restarting that move. So hopefully that logic makes sense. Now, let's say they do make a valid click, and so this would be, in other words, they are selecting a different square than they previously selected. Then we'll keep track of that square. And what we want to do with that, so if it's the first click or the second click, we're going to append it to our player clicks list. And so now if it's the first click, then it'll append to the first object. If it's the second click, it'll append to the second element in the list. And so we'll have up to 2 tuples. And so we append for both first and second clicks. So now we at this point, we have to ask ourselves the question, was that the user's second click? And if it was, then we want to do something. So here, if the length of the player clicks is equal to 2, meaning this is after the second click. If it's after the first click, then we're just waiting for them to click a second time, and we don't do anything. If it is after the second click, if length of player clicks equals 2, now we want to make a move. Now we want to tell our engine, hey, here's the squares the player wants to move. They want to move the piece on this square to the piece on this square, and can you do that for me? And at this point, we have to make another design decision. We have to decide how we are going to make the board play the moves. And we also want to keep track of the moves so we can later undo them. So there's definitely a few decisions we want to make here. What I'm going to do is make a move class. You don't have to do this with a move class. You could simply do this with pairs of tuples, update the board accordingly. I think it makes it a little bit more clear to create a move class, store all that information in a move class, and then you can do something like writing a chess notation method that will take squares and create the chess notation. So we're going to do a little bit of that. So simply said, what we're going to do is we're going to create a move class, and we're going to do that over an engine. We could do it in the main, but I think it makes a lot of sense since it's going to be kind of tied to the behavior of the game state. Game state's going to have a move log with a bunch of moves. It makes sense, I think, for the moves to be in that class. So, let's go ahead and do that. Now, Python does have capabilities of doing something called a nested class, which would look something like this, where you can see this class is inside of this game state. It's not recommended, generally speaking, to do something like this, unless you have a reason behind doing it. And in this case, we don't gain anything from doing this, and we're also not. There's not really a purpose behind doing this for this particular project, and so we're not gonna do that. But if you're curious about nested classes, you can look that up, and there are some uses for it, but we're just going to keep them in the same module, chess engine, just to make sure this is unindented. Right. So what is this class going to look like? Well, a move in chess is, let's start with our constructor like we do for classes. A move in chess basically has a start square and an end square. And we're also going to pass in the board, that the current board state, if you will, because we are going to want to validate the moves to see if well, yeah, we're going to want to make sure that the moves we're making are valid moves. And so we do want some of the information about the board, although our chess engine class is going to do the validating. Passing the board allows us to store some information about the move that we're going to need in order to undo the move. When I capture a piece with another piece, I want to store the information of what piece was captured. And that way I know, because I'm not going to be saving snapshots of the board at each move, I'm just going to be storing a move log and the current snapshot of the board. And so if I capture a piece, now that piece disappears from the current snapshot of the board. If I undo a move, but I only keep track of the beginning and end squares, then I move that piece back, but what do I put in its place? It's a little bit hard to talk through. It's maybe a little bit easier to visualize. But that's the idea. So we do want the information about the board so we can store the piece captured and the piece that's doing the capturing, so that we can undo the move later on. It makes it a little bit easier. All right, so we're going to have those 3 parameters for our constructor, and we're going to create some variables. So typically when we've done constructors with parameters, we would do something like this. In this case, we're actually going to do something a little bit different. Instead of just using start square like that, we're actually we're going to break this down into start row, which will be start square 0. Remember, start square and end square are going to be tuples. And start column. And then we're going to have end row. And end column. And this is just a little abstraction that we're going to make to help us be able to visualize a move a little bit better. So instead of having to think, we're just decoupling these tuples, and so that we can use them more easily. So we don't always have to say start square 0, start square 1. We can just use these other variables here. Again, you don't really have to do this, but I think it makes it a little bit nicer. And then the other thing we want to keep track of is we want to keep track of what piece was moved and what piece was captured. And so think about how you might grab this data from our board. So hopefully you thought, my board is a 2-dimensional list, and now I have these variables start row and start column. So I can very easily access the piece moved, and the piece moved is going to be where the start square was at the current board, and the piece captured will be end row, end column. Now, note that we're not actually making the move yet. This isn't changing the state of the board. This is just keeping track of information. So it's saying, here the user wants to move from this starting row to starting column to this ending row and ending column, move this piece and capture this piece. And this might end up being that string which we put in for an empty square, in which case no piece was captured, and that's fine. But this just allows us to have all the information about a particular move in one place. And so we can store move objects in our move log, and we can see what square was moved, what piece was moved from what square to what square, and if it captured a piece. And later on, we can add in things to deal with, like en passant and castling and some of the other like weirder rules in chess that aren't as common. But we'll be doing that in our engine as we generate the moves. All right. Now, another benefit to using a class like this is that we can make a like two-string method essentially, or a chess notation method. And I think it's valid to do something like this just for our own sake of debugging, because this allows us to kind of see what moves are happening a little bit easier. And if you're familiar with the game of chess, you know that everything is in rank file notation, and that's how they transcribe games. And I think that it's beneficial to us for us to have a method that does that. So here I'm gonna actually just go ahead and copy and paste some code in, just to, and you guys can copy this down. We're gonna use some dictionaries here to map a couple things. So as was described in Ms. McPhillips' video, but maybe I'll just show you a quick thing here. So let's just say that, all right, so you can see here I have a chess.com board pulled up, and you can see that the white pieces are on 1, 2, 3, 4, 5, 6, 7, 8 up the board. So white's on rank 1 and 2. So the ranks are called rows, and the columns are called files, and they're lettered A through H. And so instead of this notation that we're using with row and column being like here is 0, so like the piece at 0, 0 in computer notation would be this black rook. But in chess, we would say that that piece is on A8, the file that it's on, and then the rank. And that's your rank file notation. And so we're going to do something like that in our code. So I wanted to show you that. So this is what right here, these are dictionaries that are going to do that for us. So this one goes from ranks to rows. So it takes the ranks 1, 2, 3, 4, 5, 6, 7, and 8, and then goes to our row notation in terms of matrix of 7 down to 0. So 0 again was the top rank 8. And then here I do a nice little thing, rows to ranks equals, and then I use this notation here with a for loop. There's actually a for loop in here. And this is just a really cool way of reversing a dictionary. So if you ever have a dictionary that maps one thing to another, but then you want to reverse it, this is a pretty cool way of doing it. And so basically what it's doing is for each of the key and values in the items of ranks to rows, it's reversing it and saying for all the values and keys, or for each key and value, make a value key pair. So it's just flipping it. And then I do the same thing for files to columns. So you can pause the video and type those out. Now, why did I do that? And this is the key here. So we want to actually make a nice little chess notation for our move. And so that we're gonna add a function down here called get chess notation. And what this is going to do is essentially return the rank file notation. It's not going to be pure chess notation. So if you know whenever you move a pawn, you just say that the square the pawn is moving to. So and like when you capture a piece, you put an X in the notation. So you could make this more like real chess notation if you're real, if you're chess savvy and you like that, this might be something fun for you to do. Here, all we're going to really do is just do rank file notation. So we're gonna get together a string of values for our starting row and ending row. And I'm going to use a little helper method here, which I think is nice, called get rank file. which just takes a row and a column. So this gets the rank and file for 1 square. And all we're going to do is we're going to say, let's take our columns, convert it to files for our column, and let's get our rows and convert it to ranks for our row. Now, again, in chess notation, you do column then row, or sorry, you do file then rank, A8, A4, C6, whatever that is. The letter always comes first, which is the file. And normally when we do row column notation, then we put the row first. So it's a little bit reversed, which we see here. And here we're just going to call this get rank file notation on our starting row and ending row. Or sorry, our starting row and starting column. And then we're going to add it to another call to get rank file. I forgot self, end row, end column. Let's go ahead and add those back in. All right. And so this will allow us to actually see what the move is in chess notation. And again, if you feel inclined to, you can add to make this like real chess notation. Ours is kind of just rank file notation. All right, because there's a lot more logic that would go into that. I don't want to do that in this video. All right, so now we have an idea for a move. The next idea is, well, how do I? Okay, so now that I have a move, how can I make the board take a move and make said move? So let's create a function in our engine game state that makes a move. So let's say def make move, and we'll just take in just a move object. This will take a class of move. So now we can say move.start row, move.start column, move.end row, move.end column. And so it might be easy to see what this method would look like. We're basically going to, when you make a move in chess, you take the piece from its starting location and you move it to its ending location. So what does that do for the board? Well, it makes the starting row and column, sorry, we need to say move, starting row, move starting column, and it sets it to an empty piece, because when we move a piece, we leave the square behind it blank. And what it also does is it moves the piece to its ending location. So end row and end column are the piece moved. And this is why we grabbed that when we created the move. And then finally, we can, and that's all you need to do. We don't have to worry about the fact that we overwrote the captured piece, because the captured piece is going to be stored in this move variable. We also don't need to worry about validating these moves at the moment, because we're going to have something that generates a list of all the valid moves and only allows the user to make valid moves. So we don't need to actually, we can assume this move is already valid. And we're going to do that in another method. So now we just append this to a move log. And this is, so we're gonna log the move so we can undo it later. Or maybe we want to display the history of the game. And then we switch players' turns. This is pretty important to do for our engine. We want to make sure that if it was White's turn to move, now it is not White's turn to move. And if it was not White's turn to move, now it's White's turn to move. And so we're just going to simply swap players, switch turns, and that will make the move. So that's a pretty straightforward method. And it's all made possible because we made this move class. It made us nice and easy to understand what we're doing. All right, now we're almost done. We're going to go back to our main, and we're going to now call this, we're going to go create the move object and then call this make move function. And so how do we make this move? Well, we create the move object by using the move class, and the move class required us to pass in a start square, an end square, and the current board. And so our starting square is PlayerClick's 0. Our ending square is PlayerClick's 1, and our board is game state board. And you can see that this move creation is a pretty inexpensive algorithm. We're just setting 4 variables. That's pretty cheap. And then we're just accessing 2 elements of an array, which is also not too expensive. And so creating a move like this is pretty inexpensive, and actually making the move is pretty inexpensive as well. We're not using any for loops here. We're going to be using that logic later on, but we don't, as far as this goes, this is decently efficient. Now we can do something like this just for debugging purposes. So let's make sure that our code's working by, let's get the chess notation for that move, which is why we, wrote that algorithm, so we can actually see it. And then let's go ahead and make the move using our make move function. And this is, again, a function within the game state. So we need to say game state.make move. And then finally, let's see. Yeah, and then finally, all we have to do is, and this might not seem obvious right away, but we need to make sure that we allow the user to make a second move. So let's reset the user clicks. Otherwise, we won't be able to. If we don't actually say player clicks equals empty, then the length of player clicks will never be 2 again. We'll just continuously append. I guess we could. We'd have to click the same twice. So, all right, and that should be it for today. So let's go ahead and test it. We wrote a lot of code today, so there might be some typos or something like that. Hopefully not. But here we go. And so we'll test it. We'll click on a piece. We'll see if we can move it, and it moves it. And you can see it prints out the notation D2, D4, meaning we move the D file pawn from the 2nd rank up to the 4th rank here. And now black could make a move, let's say here, knight F6. Again, it's saying G8, F6. Where did the piece come from? Where did it go? And again, if you wanted to, you could make this, instead of saying G8, F6, the proper chess notation would be capital N for knight F6. And so, there's some logic there. White can make another move. Black can make another move, and we can actually play, a game of chess. Right? And so we're getting there with it, and we have all our moves being logged, so everything's looking pretty nice so far. All right, so that's where we're going to wrap up with today. And next on the plate is a couple different things. So we're going to work on recording and undoing the moves next. So what happens if someone makes a mistake and we accidentally do an invalid move like that? Right? The pawn was in the way. That shouldn't be able to happen. And we're playing, we want to undo that move very quickly, or someone makes a mistake, a blunder, and you want to let them go back. In chess, if you're playing against someone on board, you can do that. You can say, okay, you can undo your move. You can try that again. And so, let's go ahead and make that happen. And then later this week, we'll look at invalid moves. So we'll make sure that moves like this aren't possible. And so we'll actually generate the list of valid moves. And then we're going to have to spend a few days actually creating the logic for those moves. So each individual piece has a certain way that it can move. And so that's where we're headed with this. So I hope you're enjoying this so far. Just think two short videos, and we've already got a pretty cool application working. So there's a lot more we can do with it, and there's a lot more we're going to do with it. But until then, I'll see you.